Yeah, this is question 3 from our pre-response practice assignment on areas under the curve of accumulation, all the stuff we've learned up into Unit 6 so far. So, the graph of f is shown above, consists of a semicircle and 3 line segments. Let g be the function given by g of x equals the integral from -3 to x of f of t dt. Going ahead to write that down, -3x of f of t dt. G of x equals. Okay. Let g of x looks dreadful. Not that it matters, but it matters to me. Okay. Find g of 0 and g prime of 0. And again, same question that we've had on all of them so far. So again, I'm not going to really explain. G of 0 is going to equal the integral from -3 to 0 of f of x dt dt. And so g of 0, -3 to 0. I'm just finding the area of this trapezoid. And then yes, I can cut it up and make the triangle. I'm going to go ahead and use the trapezoid though. Actually, I'm just going to count that the answer is 4. If I think about this rectangle, which would have an area of 6, and maybe it's not. This triangle is 3 times 1, and half of 3 is 1.5. So just kidding. It's equal to 4.5. Again, this triangle right here, 1 times 3 divided in half is 1.5. So 4.5 plus the 3 under v. Okay, g prime of 0 means I need g prime, which is equal to f of x. So what is the value at 0? The value at 0 is 1. And again, if you want a better explanation, watch my last video, or actually video 1. Find all values in the open interval from -4 to 5, which g has a relative max. So again, g will have a max when the derivative is equal to 0. And change the sign. Max from positive to negative. So from positive to negative. So when g prime is 0, from positive to negative. All right. So I'm looking for g prime is f of x. So I'm looking for where the function is equal to 0. And g prime of x equals 0. And I'm using this pen. X equals -4, 1, 1, and 3. It changes sign from positive to negative. So this one's a min. This one does not change sign, so it's neither. And the max is at 3. So we have a minimum, neither, and a max. So x equals 3 is a max because g prime of 3 is 0. G prime of x is greater than 0. from -4 to, actually we'll just go from 1 to 3. Because at 1 it's not positive, it's neither. From 1 to 3. And g prime of x is less than 0 from 3 to 4. So it changes signs. Good, match, done. Next, B is part C. Part C says, find the absolute min on the interval, the closed interval from -5 to 5. So we know that we've got our this is a candidates test. Candidates, yeah. Because absolute min, excuse me. So our candidates are x equals -5, x equals +4, and x equals -4 relative min. So those are my candidates. And so I need to find, I'm going to make my candidates. Start with -5, -4, +4. I need to find the absolute min, so that means I need g of these values. So g of -5 is equal to the integral from -3 to -5 of f of t dt, or in other words, the area from -3 to 5, which is 0. From -3 to 5, these two will just cancel each other out. The area is 0. The integral from -4 will be equal to integral from -3 to 4, -4 of t dt, which, going backwards, recall, this area is 1, so but it's -1. As we mentioned in video 1, when we go, if we're starting here and finishing there, we have to kind of think of it in reverse, so it's going to be -1. That's -1, and then at 4, that's my other endpoint, the integral from -3 to 4 of f of t dt. So I need my picture now a lot to do this problem. So I'm going to go better, I just need it here. Okay, so the area here we already found was 4.5, so we know this area. The area under this curve, we'll get back to that, and then this area is 0. So we broke this up into the integral from -3 to 0. We're going to add to that the integral from 0 to 2 of f of t dt, which we're going to add to the integral from 2 to 4 of f of t dt. Okay, this one, last one is 0. That one's we already got from a previous problem. From 0 to 2, we have the area under the circle curve. Okay, so it's a little bit funky, but if we think of this as a rectangle of an area of 2, we have to subtract the area of the half circle minus 1/2, because it's half a circle. The radius is 1, pi r squared, r is 1, okay, and so that will give me 2 minus pi halves. That's my area in the middle. I can stop right here. That's my answer. I'm going to go ahead and clean it up just a tiny bit and write 6.5 minus pi over 2. That's my area. Okay. Okay, let's go back to the question. So I wrote this over here, 6.5 minus pi halves. Wait, that's our question. Find the absolute min of G on the closed interval. It wants to know the absolute minimum value, which is -1. Okay. Okay, that's that. Last but not least, D. Part D says, find all values of x in the open interval where there's a point of inflection. So points of inflection will occur when the second derivative is 0 or undefined, which is very important in a curve like this, where it's not really, we don't have a lot of horizontal tangent lines. So looking at my graph, the slope, we're looking at the slope of f now. Okay, so undefined at -3, undefined at 0, horizontal, so slope of 0 at 1, undefined at 2. So possible points of inflection are x equals -3, 0, 1, and 3. Oh wait, excuse me, not 3, 2. These 1, 2, actually, yeah, we'll say it like that. These 2 are, these 3 are undefined. This one has, the second derivative is 0. Okay. So points of inflection occur when the derivative changes signs. So that's a point of inflection. This is not. Slope is negative to negative, still decreasing. This one is. From positive to negative. Slope of f changes from negative to positive, and here from, see how it changes, but here it doesn't. So that point of inflection is not. And then here. And at 2, this is also a point of inflection. That one's because it goes from positive to negative. And that's it. I just want to know the values. So x equals, and our justification would be, because those are the ones where it changes, x equals -3, 1, and 2. 0 is not. Sign doesn't change. Sign of f double prime does not change. Okay, there you go. That's it. All right, have a great day.